So here we have a GM linear solenoid valve for EGR, and we guessed it was on a Lucerne, and we were kind of right, or Jack guessed. So we found a pinout for a GM one, and so the ohming of the two end A and E is about 11.4 ohms, so we decided to put 12 volts to it. So we'll see what happens whenever we put 12 volts to it.
Alright, so we have our positive and ground leads hooked up here. We're going to run 12 volts across the solenoid, then it should open. So you can see there when we run 12 volts through and disconnect it, it will open and close.
So now we're going to check the potentiometer inside of the EGR valve. So we have the leads on the signal and the ground of the potentiometer. So what Jack's going to do, he's going to push the pintle in, and we're going to see the resistance increase as he pushes it in, and that's in all the way. And then when he lets it back out, the resistance will decrease. So there it decreases. And then if we put the min-max function on meter and he does it again, it'll beep for a min and a max, and then when he lets it back out, then we can click min and max and see that there was not an open or a short on potentiometer respectively.
So we have a cutout version of the EGR valve. So starting at the bottom here, we have our pintle, which on this one it opens downwards. And then moving upwards, we have our spring that when the solenoid is not engaged, it will push the valve back closed. And then on our solenoid, we have our windings here, which you can see are a bunch of little copper wires along with our magnet. So when it is activated, it'll pull this magnet down and open up the pintle valve. And then at the top, we have our potentiometer that can read where the solenoid is and how far open the pintle is.
So here we have the schematic for our EGR system on the TL. So we have our potentiometer on this side with the 5 volt reference voltage going through the resistor, and then the sensing circuit right here. And then we have the actual coil wire that controls the pintle on pins 4 and 6. So we'll get our power from the PCM, and then that goes into our ground 101. And so when this gets power, it'll lift the pintle up or down, whichever one this direction goes, and this potentiometer should show that it has moved. And so the PCM should know that, hey, if I send power here and this potentiometer does not read a different voltage, then there's something wrong with the EGR valve itself. So that, in theory, should set a code.
So we have our lead back probed into the 12 volt feed that opens the solenoid. We're going to go ahead and jump it straight to power. So you can hear when the solenoid opens and the valve opens, it does actually bog down the engine because it is feeding exhaust gas into the cylinder. When we let off, the engine starts running normally again because there is a cylinder full of good gas and good air rather than already burnt exhaust gases.
And so now our vehicle is running, and we unplugged the EGR valve, and it's still not doing it doesn't do anything like it was when we shorted it, because it's already closed at idle, because we don't want EGR working at idle, So an interesting to note on the scan tool here is we have an EGR VLS, not sure what VLS stands for, but we figured out that it is actually the solenoid-like potentiometer. So whenever Jack is going to tap it and short it, you see that the graph starts to go up. And so then that's when our valve opens, and this is when our valve is closed. We opened it a couple times earlier, as you can see. But here in shop at idle, no matter how much we blip the throttle, it's not going to move the EGR valve because it's at idle and a decently low load. But thought this was interesting, so thought we might include it. So we're checking for vacuum with the oil filler hose, and our paper stays pretty well. The fans are going pretty high, but it does stay pretty well. So here's the PCV valve, and this side goes to the intake, and this side goes to the crankcase. And if we shake it, it's in there, and we can see the little thing moving. You can see it move. So, doesn't necessarily mean it's good, but it's a good sign that it is good. it made a leak by unplugging the suction side of the hose, and our fuel trim went up significantly, very significantly. And so if we plug that back in, leak stops, and then it should stay up. Might take a second to get back down. But we can see it's going down slowly but surely.
Have you got a PCV system on now?